Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone watching this video. Today we are back to another series of learning, and today's topic is very interesting since I have a lot of stuff to discuss about this topic, which is application of logic in real life, which we relate something in mathematics into the real life situation. So before we going into more further, we would like to thanks to Madam Suziana Aida binti Othman for having taught us a lot of stuff during our classes in MAT210 discrete math. So we are so grateful to be learning a lot of mathematics from you, Madam. Before that, let us introduce ourselves first.
Assalamualaikum, my name is MOHAMAD ALTAMIS THAQEEL bin ABDUL SHUKOR and my matrix number is 2022-855-314.
My name is Tengku Ahmad binti ASHRAF. My matrix number is 2022-616-874.
My name is Muhammad AIMAN bin Muhammad RAMLI. My student ID is 2022823292.
So, without further ado, let's get to know about the title of our project, which is From Algorithm to R.
Now, I will start our presentation with the definition of mathematical logic. The study of reasoning is called logic. Specifically, it asks if the logic is sound or not, rather than concentrating on the details of any one assertion. Logic emphasizes the connection between claims. To decide if an argument is legitimate or not in our daily lives, we always apply logical thinking and reasoning. Logical reasoning and thinking have many applications in a variety of professions. Logic is a set of principles that assesses the truth or falsity of conclusions using reason. This topic will provide you an introduction to determine the truth of or false of a complex statement by dividing it into a set of clear statements whose truth or falsity is clearly seen or easily to understand.
Now we finally have come to the usage of mathematical logic. I have 3 key points to highlight here, which is a concept that were chosen to guide us in resolving the provided issue and were used to arrive at our conclusion. It became clear from applying these ideas that they were more than simply theoretical frameworks. They were also helpful in solving problems in day-to-day living, just like a switch light or something like a fan or even an air conditioner. By purposely using inference rule, mastery logical connective, adhering to logic law, and comprehending switches network, we were able to successfully navigate the challenge of problem solving and produce conclusive and well-founded answer. So, what is the 3 concepts that were chosen on guiding us? The 3 key points, the 3 concepts that were chosen. First one is switching network, the second one is logical connectives, and the third one is validity of arguments.
Switching network. A mathematical model known as a switching network is used to explain how switching systems, which are essential elements of digital circuit design, behave.
Now, how about logical connective? A logical connective is a symbol which is used to connect two or more propositional on predicate logics in such manner that resultant logic depends only on the input and the meaning of the connective use.
Now I will explain about the validity of arguments. The argument consists of a series of statements with premise and conclusions. The remaining statements are referred to as premise, and the final assertion is termed the conclusion. For instance, input P indicates their preferred football team, input Q indicates the teams they detest, and input R indicates the larger number of spectators.
Now we finally met at a case study. If you look onto the image, you can clearly see what type of case we are studying right now, which basically are air conditioner, fan, as well as window, while also determining the temperature of cool level in this table. Now let's look onto the first question and try to solve the following proposition while comparing it to the fan, window, as well as air conditioner. For example, on the question A, the proposition are not A and B or A and B are equivalent to F. Let's see whether it is equivalent or not logically equivalent. For example, in the first column we have true, true, false, false, and the second column B, true, false, true, false. Now we have the third column not A, false, false, true, true, and the fourth column is not A and B, where we get the true value is false, false, true, false. How about A and B? We get true, false, false, false. And now we finally have the two matched together where not A and B or A and B are true, false, true, false. Therefore, we can see and try to compare it with the fan whether it is equivalent not or not logically equivalent. For example, in this situation, not all true values in column 6 and column 7 are equal. Therefore, not A and B or A and B not logically equivalent to F.
Okay, and now for the question B, not A and B logically equivalent to W. So I'm going to start to read from the first column. The true values in column A, true, true, false, false, and in column B, true, false, true, false, and in column not A, false, false, true, true. And for the fourth column, not A and B, false, false, true, false, and comparing with the window, we can make a conclusion that since not all true values in column 4 and column 5 is not equivalent to each other, therefore not A and B is not logically equivalent to W.
I will be the one that answer the question C. The question C statement is A and not B or A and B logical equivalence C. So we will make this table with A is true, true, false, false, and then second one is B, true, false, true, false. And now we will make the not B, false, true, false, true. And now we'll make the A and not B, false, true, false, false. And now the A and B, true, false, false, false. And now the statement A and not B or A and B, true, true, false, false. And the logical equivalence A conditional C is false, false, true, true. So the conclusion is, since not all true value in column 6, not column 7, therefore not A and B or A and B is not logical equivalent F. Now the summary. The truth table reveals the optimal configuration for cool air in a system. Switch A should be on while switch B should be off, ensuring the air conditioner operate while keeping the fan and window closed. The combination of both switch open the air conditioner and fan while keeping the window closed, creating a cooler room temperature. Understanding this switch help tailor environmental condition for desired comfort, contributing to system dynamics and control mechanism. The truth table provides guidance on optimal switch setting and synergistic operation of components. Understanding this switch helps tailor environmental condition for desired comfort level. This insight contributes to a broader understanding of system dynamic and control mechanism.